Okay, start recording. All right, so we've got
Get that.
first times derivative of the second. So that's going to be 4t minus 4 to the negative 1. And I'm going to put a prime there. Plus the second times the derivative of the first. (6t minus 1) times, and I'm going to do this and do it in green. That's going to be negative 1 times 4t minus 4 to the negative 2 power. Well, I'll tell you what. I don't know how many people suck at this, and I don't know how many people created it, so I'm going to just make sure I teach to the people that don't know how to do it. Negative 1, negative 1 minus 1 plus 4t minus 4 to the negative 1 times 6. All right, so we just took the derivative. So now let's clean it up a little bit. And really the only thing we can clean up is the negative. We can pull that way out front. Everybody with me? Pull that way out front. That's going to give us negative 6t minus 1 times 4t minus 4 to the negative second power plus 6 times 4t minus 4 to the negative 1 power. And of course, you know that the negative exponents come what? Downstairs. So I'm going to take my handy dandy cursor and I haven't had training. Put that right there. Everybody with me?
Yes, sir.
Yep.
Why did that mess up? Something didn't work right. Hold on. Yeah. Shoot. There. Now it's going to work. Since I don't have poster board, I have to do this. Got to be innovative for y'all. Okay. So now we got to get a common denominator. Oh, well, we got to get the denominator. So it's going to be negative 6t minus 1. And I'm still going to put parentheses around that. Over 4t minus 4 to the second power. Plus 6 over 4t minus 4 to the first power. Now, of course, let's go back to pre-algebra. If you have 1 over x plus 1 over x squared, if you get a common denominator, what do you use? The lowest power or the highest power? That's not rhetorical. You use the highest power. So I'm going to use the highest power, and I'm going to get a common denominator of x 4t minus 4 quantity squared. So I'm going to go down here, and I'm going to do this out because, like I said, 90% of this is algebra, but somebody might go, what the heck did you just do? So I'm going to get a common denominator, and I'm going to convert. So I've got my common denominator to the second power. Now I'm going to convert. And of course, 4t squared going to 4t squared one time. 1 times this is that. So that doesn't change. Negative 6t minus 1. And then over here, 4t will go into 4t squared, 4t times, so that's going to be 6 times 4t minus 4 to the first power. There we go. So now we've got everything over one denominator, so I'm going to just draw a little arrow right here, and I'm going to do one denominator of 4t minus 4 to the second power. And now that distributive law, that'd be negative 6t plus 1, negative 6t plus 1, and then plus 24t minus 24. Y'all check my algebra. And negative 6t plus 24t is, I have no idea, 18t. That's 18t. Plus 1 minus 24 is negative 23. Now, why am I going to stop there? Because 23 is what? What's 23? It's a prime number, and you're not going to get much to go into 18 and 23. Now, that's what I got. What'd y'all get?
I do have one question.
Oh, God, did I make a mistake? Hello, that's Miss Rowland. I made a mistake.
I don't know. On the second line at the top, were we supposed to do the chain rule on the 4t minus 4?
You're right. And I said, didn't I say we're going to use the chain rule?
Yeah, that's why I was
My
asking.
bad.
It's
I wish
okay.
you'd have said something back then. Which is only 4, isn't it? Yeah, 4. My bad. That's why communication is so important. See, it's your fault, Miss Rowland, that you didn't catch that before. It's your fault. So that's going to be a 4. That 4 comes right here. And 4 comes out right here. And negative 4 is going to be, what's negative 4 right here? That's going to be negative 24 plus 4. See, y'all are communicating right now. Y'all are not communicating. So thank you very much. Negative 24t plus 4 plus 24t minus 24. Yes or no? 4t
Yes, sir.
minus 4, quantity squared. And the 24t's cancel. And 4 minus 24 is negative 20. So that'd be negative 20 over 4t minus 4 quantity squared. Check, make sure. I hope I did that negative 4 all the way through. Did I? Let's see what the answer is. Make sure I didn't screw it up. Thank you, Miss Rowland, for catching that, even though I said chain rule before we started. I didn't do the chain rule. But you can see that, you know, it's pretty simple to make a careless mistake on these things. Well, what the hell was the answer? Why does it do that?
It was the 20.
Was it
negative
the
20
answer? I didn't see it.
It popped up and then you clicked it a little fast. Yeah. You just clicked it fast, so it gave you a similar problem. But it had the negative 20 on top with 4t minus 4 squared.
There it is. Everybody see it? Okay, so let's do another one. Why do I want to do another one? Because this is a very, very good test question. This is the kind of test question I would pull, I would get y'all to do on a test. Okay? So let's do this one. And hopefully I won't screw it up and forget to do the chain rule after I tell you to do the chain rule. So we got 2t minus 1 times 4t minus 3 raised to the negative 1 power. These are the type questions that if you can do these questions, you've got 3.1 through 3.4 covered. Oh, Lord. Easley just went out. Easley, are you there? Bless her heart. Miss Sterling, I'm adding you. There she is. Miss Sterling, you there?
I'm here. I have no idea what Easley's computers are doing.
I'm sorry, what?
I have no idea what Easley's computers are doing. They just keep shutting off and on again.
Well, I'm glad you. How far were you on the last problem?
You were starting off your explanation of that first question.
Okay, let me give you the answer, and you work on that one. Not now. Work on this one, the one I got on the board now. Same problem. The answer to that last problem was, I done forgot, negative 20 over 4 what?
Over 4t minus 4 squared.
That's the answer to the last problem. So write that down, Miss Sterling, please. And you can try that one at home. And I'll do this one. We'll do this one, and then you can use this one for a guide, because it's the same type problem. And I am recording it, so you can go, when I load it, you can go over the recording also. Now, could you put this in a quotient form and do the quotient rule? Yes, maybe, no?
Yes.
Yes, you could. So, we'll do both. So I'm going to do first times the derivative of the second plus the second times the derivative of the first two t minus 1. We'll do it this way first, and then we'll do it with the quotient rule. So that's going to give us, I'm going to start you off, 2t minus 1, and I'm going to do the derivative in green. So that's going to be negative 1 times 4t minus 3 to the negative 2 power times 4. Now, I don't know how far you got, Miss Sterling, on the last one, but I did the cardinal rule. I told y'all to use the chain rule, but I forgot to use the chain rule, and I forgot that 4 right there. So don't forget that. Plus 4t minus 3 to the negative 1 power. And I'm going to take the derivative, and that's going to be 2. Okay, now it's 100% algebra. There's no more calculus. So I'm going to give y'all a minute to work on that. Now, Mr. Hitt, where is he? I mean, we still got 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, okay.
Did I miss anything? Okay, I think I did.
Yeah, I just wrote the answer. How far were you when it went out with you?
Not very far.
Okay, let me put the answer down. I'll put
All
the
right.
answer to the previous question in magenta at the
Okay.
top. It's negative 20 over parentheses 4 what? 4t? Minus 4 to the second power.
Okay.
Now, I'm going to tell you, just like I told Miss Sterling, because she got cut off too. On the previous problem, I told you to use the chain rule with the product rule, but I forgot to use, and I know why I did it now. Remember when I was putting that step in here, and I told y'all that I would put a baby step in here with that -1 and that -1? Well, while I was concentrating on that, I forgot to do the chain rule. And I forgot to put that 4 out there. So don't forget this 4, because that's the derivative of 4t minus 3, because you got to use the chain rule right there. And
Okay.
I don't know if I got that far with you before you cut out, but
Right. Well,
all right. So 2t, I'm gonna bring this -1 and this 4. I'm gonna bring it out front. So that's -4, 2t minus 1, 4t minus 3 to the -2 power, plus 2 times 4t minus 3 to the -1 power. Now at that point right there, you're still using algebra. There's no more calculus. So you've got to bring those negative exponents down. And when you bring those negative exponents, really, you're going to pick that one thing out of there. God. That's what's so frustrating about not having training on this. Sometimes you can hit one letter and you can drag the whole thing up. And then other times you have to do what I'm doing right here just to move it. Very, very annoying. And it's grabbing that too, so that's going to go up there too, so I'm sorry.
Just to let you know,
One day we'll have training. One day.
I got some of those black pieces for your pen tray.
Thank
They're on the
you.
way, and Sandra should be able to install them and then recalibrate, and it should be more accurate.
Thank you very much.
I hope.
I hope, and I appreciate that.
No problem.
Okay, so I'm going to bring these down. I'm going to bring this down because of the negative what? Exponents. So that's going to give me -4, 2t minus 1 over 4t minus 3 to the -2 or +2 power. That's a positive. Plus 2 over 4t minus 3 to the first power. Now, of course, you've got a common denominator. You're going to use the highest degree. So the common denominator is 4t minus 3 to the second power. 4t minus 3 to the second power plus 4t minus 3 to the second power. And now you're just going to convert. 4t minus 3 to the second power will go into 4t minus 3 to the second power one time. 1 times -4, blah, 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 is -4, blah, blah, blah. 4t minus 3 to the first power will go into 4t minus 3 to the second power. 4t minus 3 to the first power times 2 is 2 times 4t minus 3 to the first power. And that is going to give us -8t plus 1. And then 8t minus 6.
It's -8t plus 4, or yeah, plus 4.
Plus 4. Okay, thank you. And over 4t minus 3 to the second power. And the 8t's cancel. And 4 minus 6 is -2. So that's going to give us -2 over 4t minus 3 to the second power. Did y'all get that?
Yes.
Now, do it with the quotient rule. Now, should you do the quotient rule and the product rule whenever you can? Yes. Because it's called extra what? Practice. Y'all know I'm being sarcastic when I say that word practice. Y'all know that, don't you? Y'all know I'm not, having problems. So I do have problems sometimes, but, not when I say practice. I'm being sarcastic. Do y'all all talk this much at home?
Yeah.
What the hell was that? Did y'all hear that?
Yeah, I've heard it several times.
Yeah,
Somebody
that's
trying
not
to
the
be
Sound
first
like an
time.
auto-tuned chipmunk.
I never
I think
did
it's
like
someone's mic
Alvin
that's
and the
messed
Chipmunks.
up.
Did y'all like Alvin and the Chipmunks? I never did like Alvin and the Chipmunks. I wanted to step on them when I was little. I never did like them. Uh-oh. Okay. It's Mr. Okay, Mr. Brock, is that what yours microphone does?
Hello?
Keep that. Yeah, keep that.
Is that better?
Yeah, that's better.
Yeah.
Okay.
Okay, whatever. All right, so we're going to erase this, and we're going to see if we get the same answer using the quotient rule. And like I said, anytime you can do 2 problems for the price of 1, do it. And later on, you're going to be glad you did. So 2t minus 1 over 4t minus 3 to the first power. So using the quotient rule, I'm going to go up here because I don't feel like moving everything. Denominator times the numerator prime, things I do for y'all, 2t minus 1 prime minus the numerator, 2t minus 1 times the denominator prime, 4t minus 3 prime over denominator squared. So 4t minus 3, I'll do the derivative in green. What is the derivative of 2t minus 1? Well, magenta. Minus, I'm going to leave that in red, and I'm going to do that for a reason. You know why. And we'll take the 2t minus 1 and magenta. What's the derivative of 4t minus whatever?
4.
Oh, that magenta and that red clashes. All right. All over the common denominator, or the denominator of 4t. I'm not going to worry too much about that. You can put that in your final answer. I'm not really worried about you writing it 5,000 times. Okay? So, looks like to me, algebra. So that's going to be 8t minus 6. And over here we've got 8t minus 4. But what is that negative going to do? It's going to make it 8t what? Plus 4, right? Yes, all
sir.
over the denominator squared. The 8t's cancel. Negative 6 plus 4 is negative what? Did we get the same answer? That's not rhetorical. I'm asking y'all to answer me.
Yes.
Now, some of you may think the quotient rule was easier. Sometimes it is, sometimes it's what? Sometimes it's not. Anybody got questions on these two that we did? Let's check to see if we know what we're doing. Negative 2 over 4t minus 3 to the second power. And for those who don't know what the squiggle is 4t minus 3. Those are two good test questions. So whoever sent that question, that was a good test question. Anybody got a question on these two? Okay, now let's get to a little bit of what new stuff. And this is 3.6, I believe. 3.6. I'm just going to go to the whiteboard. Okay. Now, in this section, we're going to talk about how derivatives can be the context of the question versus the first, second derivative and all that good stuff. Okay? I told you the other day that sometimes the first and second derivative will give you your local min and local max, your vertex, and your concavity, or whatever you want to call it. It also give you your first and second, which is acceleration and speed and acceleration and jerk. First, second, and third derivative. All right? So why do you need to know that? Well, you need to learn to start reading the questions and knowing what they're asking for. So in this case, sometimes, and I've already went over this with you, there's two things. There's called the average velocity. And I want you to really highlight average because I'm going to get into that in just a second. And there's the instantaneous velocity. Now, the average velocity is a 25-cent word. When you see that word average, I want you to think of, and I'm going to put this in red or green because it's very important that you remember it. When you see the word average, average cost, average whatever, okay, average growth, average velocity. When you see the word average, I want you to start associating that with this word. Slope. So when you are asked to find the average velocity in 5.6, average velocity is a 25-cent word for what? Slope. That means you pick 2 points and you find the what? I'm asking for interaction there. I wrote the word in green.
Slope.
Thank you. Y'all suck. Anyway, we got a line. We got 2 points. And yes, it will be the secant line. That's what the average velocity will be. The average velocity will be the secant line. Write that down. Or the average growth, or the average whatever, velocity, average, whatever. Whatever they ask for average, it's going to be the slope. So you're going to take those 2 points, and you're going to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So why am I telling you this? Because sometimes they will ask you a homework question, and they will ask you a test question, and they'll just say find the average velocity, and you're doing the first, second, and third derivative, and you really don't what? You don't have to. All you do is what? Y sub 2 minus y sub 1 over what? X sub 2 minus x sub 1. They're just asking for what? The slope. So don't fall for that. When they ask for the first derivative, they're asking you for the instantaneous velocity versus the average velocity. And what is the instantaneous velocity? If the average velocity is the secant, somebody tell me, with good critical thinking skills, what is the instantaneous velocity?
Tangent?
Good job. And what happens to get the secant to get to the tangent? Dang old x. Dang old x plus what? H. H goes to what? 0. And that secant line becomes the what? Tangent
Line.
So the instantaneous velocity, where the average velocity is the slope, the instantaneous velocity is the first what? First derivative. Which means that it's the equation for the slope. And I'm doing this over just for a reason. Of the what line? Of the tangent line. And the slope of the secant line is your average velocity. Now it's very important that you know that, because I guarantee you're going to see a question written on the test or the homework, and it's going to ask for the average velocity. And if you don't remember this, you're going to try to do the first and second and third derivative or whatever, and you're going to get it wrong every single time. Here's an example. And I got to write it. This is one of those that I cut and pasted onto this whiteboard 5 or 6 times, and I finally gave up on it because every time I did it, the internet was going to be out. So I quit doing it. So I got to write it. Which I hate to write it because it takes me longer. But anyway, I'm going to ad lib. Following figure shows the position function of an airliner. Okay, airplane, Seattle to Minneapolis. Airplane, oh crap. Airplane from Seattle to Minneapolis, and I'm not even going to try to spell Minneapolis. Okay? And S is equal to f of t. They're going to give you a function for t. Number of ground miles is the number of ground miles. T hours. Take off at 6 a.m. Take off at 6 a.m. They give you a, of course, that's why I had all this cut and pasted. And this is going to be 400, 800, 1200, and 1600. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they go to 8, so 8 is all I need. Let me just see if I can, let's see. Give me a second. I'm trying to get this graph to look right. Just give me a second. Everybody got that So the plane goes up. After 2 hours, it's up at a certain blah, 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 and then it levels out, and then it comes down. Okay? It's at 6 a.m. These are hours at 6 a.m. Everybody got that? Hours since 6 a.m. Okay? And they want to know, here's the first one. A, calculate the average velocity from t is equal from 0 to 1.5 hours. B, calculate the average velocity from t is 7.5 to 8.5. C, at what time is the velocity equal to 0? And D, determine the velocity of the aircraft at t is equal to 6. Determine velocity of aircraft at t is equal to 6. Now this is the type of question you would get either on a test or a homework question. And I can tell you right now that you really don't have to use any calculus in at least the first 3 problems. And you really don't have to use it in the last one. There's no calculus here. But the way that it looks and the way that it sounds, you might be led to do some kind of derivative or something. Well, first, they don't even give you a function, so you can't do the derivative. But how would you do the average velocity? Average velocity means slope. Average velocity means slope. At what time is the velocity equal to 0? Well, that's, you're looking for the vertex, or you're looking for what? Flat line or horizontal line. And D, determine the velocity of the aircraft at 6. So what do? Well, the first thing you do is the average velocity at 0 and 1.5. Now, that's why I had all this cut and pasted, because it's a whole lot easier to do when the graph is correct and it's not drawn. But like I said, after the second time I cut and pasted, I just gave up. So A is going to be 1.5, and I'm just going to write A right here. Well, I'm going to write A right here, and I'm going to do the math, and then I'm going to erase it. It's going to be S of 1.5 over, why do they have to confuse things? Basically, 1.5, here's your 1.5 right here. There's 1.5. And t is between 0 and 1.5. So 0, this point at 0 is 0 comma what? 0. And this point right here is 1.5, and I'm going to give you the actual, should be 600. So I'm a little bit off, I'm sorry. It's right here, 600. Y'all get the point, I hope. Now, how do you find the slope? I'm going to draw the slope in whatever color I got right here. There, I want to find that slope. So what do? 600 minus what? Minus 0 over 1.5 minus what? 0, and somebody takes 600 and divide it by 1.5.
$400.
So what is the average velocity from 0 from takeoff to 1.5 hours, or 730? 400 miles per hour. That's your average. That's your what? You're climbing. Because acceleration, what is acceleration? Acceleration is what you do when you go off at the red light. Okay? Are you going at 55 miles an hour when you start at a red light? No. Acceleration is what you build up to. Always remember that acceleration is like the building up, whereas the speed or the velocity is what you're going. Okay? So the velocity or the speed or whatever, because some physics teachers have conniptions when you call speed and velocity the same thing, or rate. Okay? They have conniptions, but the average velocity is 400 miles per hour. Now, what is the average velocity on the descension? What is the average velocity from 7.5 to 8.5? Well, 7.5 to 8.5. 7.5 is right here, and 8.5 is right here. Again, you've got a secant line. And I'm going to give you the points. So this is going to be just about 0. This is 0. Give me a second. This is 8.5, comma 0. And this is 7.5, comma 300. So 300 minus 0 is 300, and 8.5 or 7.5 minus 8.5, yeah. Or 0 minus 300. 0 minus 300. So B is 0 minus 300 over, what, 8.5 minus 7.5? And of course, you come out with what? Negative 300. Well, Hubert, you can't go negative 300 miles an hour. No, you can't. But what does the negative tell you? The negative tells you that you are on your way back, or you're on your way down, or whatever the case may be. Okay? So, the plane takes off here, and what's it doing here? Landing. So, technically, you're going the opposite. This slope is positive. This slope is what? Negative. And of course, the last two questions basically revolve around this right here. Because what's the slope here? The slope is 0, so your acceleration is going to be 0. Now that's just a little that's a little problem that they give you, and you probably see it in your book also. But the reason they give you that problem is to show you that you could have a question in calculus and not have one bit of calculus in it. Okay? These are just algebra problems. Let's move to the next question, or the next thing. And this is very important. Velocity. And I had this cut out also, but it's in your book, but I can't tell you what page it's on because, like I said, I had it when I cut it out. F prime of t, acceleration, if I spelled that right, is F double prime of t. And I'll go ahead and tell you right now, the change in acceleration, which is also called the jerk, is F what? Triple prime of t. And you can put in there change in acceleration. The best example of a change in acceleration is when you have an automatic transmission and you floor it. Okay, you start off, or you don't floor it, but you start off, what happens on automatic transmission when you get up to 20, 25 miles an hour? What does it do? It shifts. Think of the jerk as a shift, because that's what it is. And it basically, you know how we found the inflection points? Well, that's kind of like what you're going to be doing with the third derivative, okay, to find the acceleration. But that's later on. I wish I had what time is it? Because I know y'all have to go. We only got 50 minutes in class. I want to show y'all something right quick, because I think it's important that you understand it. Let me go to my handy dandy book. I want to find it because I had it cut out. And when this computer gets cut off, everything that I do gets erased. So that's why I didn't. Let me go to here. Go to 140. Go to the book. What did I tell y'all this was? 3.6?
You didn't say.
I think this is 3.6, isn't it?
Yes, sir.
Thank you. I knew somebody was paying attention, maybe. Okay, so 3.6. There's a reason I'm showing you this, and I don't want you to think I'm just... And I'll be honest with you, I can't remember half of it. Right there. No, that's not it. At least that's not what I'm thinking of. Give me a second. I think that must be it, but I thought it was on further. Yep, that was it. That right there, I'm going to blow it up for you. You need to write that down or put the page number at least. Page is 180, page 180. And I want you to just write that down, because sometimes it kind of helps, especially for some of you that like to write in the terms of math. I don't. Velocity at time t is the first derivative. And sometimes you're going to see the speed written as the absolute value of v, which is equal to the absolute value of the first derivative. And of course, you're going to see the acceleration written as the second derivative. So that's where I got that from. You're also going to see some more. We're going to do an example like this one right here, or an object moving along a line. We're going to try something like that. So, let's look at this problem that I've got, and I'm trying to find my whiteboard. There we go. What the heck? Oh, I'm sorry. That's the thing I cut stuff out with. Okay, here's the question. Suppose position of an object is moving horizontally after t seconds, and it's given by the equation s is equal to t squared plus 4t minus 3. Suppose position of an object moving horizontally after t seconds is given by S is equal to negative t squared plus 4t minus 3 t. For 0 less than t less than 5. So 5 seconds. And we're going to find the velocity, we're going to find the acceleration function, and we're going to find the velocity, the acceleration when the velocity is equal to 0. So we're going to find several things here. And it's really not that difficult, but I wanted to write it a certain way because some of you may see this. V of t. V of t, the velocity in respect to time, is the function derivative, first function derivative, but you may see it written like v of t. You may see it written s prime of t. They're both the same. Okay, this is the function seconds, feet per second. So that's where you get the, and they're just saying the velocity. This is the velocity is the first derivative of the speed. Okay, so that's going to be equal to, what's the derivative of negative t squared plus 4t? So we're going to do this in blue. That's going to be s prime of t is equal to negative 2t plus what? 4. So now you've just found your instantaneous velocity. Okay? So what if I want to find the acceleration? Well, the acceleration is going to be a of t. That's a. B, I want to find the acceleration. Well, the acceleration is a of t, which is the derivative of v of t, which means it's the second derivative of what? S of t. Does everybody understand that? These are the three ways you can see acceleration. Acceleration in time in respect with t versus the first derivative of the velocity in respect to t, which is equal to the second derivative of the speed, the function itself in respect to t. And what is the derivative of negative 2t? Yes, that's interaction. Thank you.
Negative 2.
Thank you. Sorry. Negative 2. Well, some of you may be saying, well, Hubert, again, how can you take the first derivative and say that it is increasing and decreasing values and find the vertex, as well as it's the velocity versus the acceleration? And I thought you said acceleration gives us a concave up or concave down. It depends on the context of the question. If the context of the question is asking you an algebraic graph, then yes, the first derivative is going to give you increase and decrease in values, and it's going to give you the acceleration. But, the concavity. But if it's asking you for speed, giving you a quadratic function, which is depicting the speed going up and speed going down, then you're going to be getting the velocity and the acceleration. It depends on the context of the question. Question, gripe, complaint. All right, that's enough for today because that's enough for y'all to chew on. I want to finish 3.1 through 3.6. I want to finish it next week, Monday and Tuesday. I want to finish it. So I want you to start working on 3.6. I got to open up all the homework, don't I? I need to do that after class. I want you to work on 3.1 through 3.6 because I want to give a test on 3.1 through 3.6. I want to give you a test probably the first of the week, not Monday or Tuesday, but maybe Wednesday. Okay? Question, great, complaint. Hold on.
So all the homework is still due tonight, right?
Well, I'm going to